Cool. 972 equal rational numbers. Given strings s and t, each of which represent non-negative rational number, return true if and only if they represent the same number. The string may use parentheses to denote the repeating part of the rational number. In general, a rational number can be represented using up to 3 parts: an integer part, a non-repeating part, and a repeating part. The number will be represented in one of the following 3 ways. And then you have 3 ways. Okay. Cool. And you have to see if they're equal. Is that it? Okay. Annoying, but not so bad. Except for maybe this one, the rounding up thing. But okay. So, how do I do this? Okay. I mean, I think we just parse both of them and then into a rational number class. Maybe that's probably the way to go. I don't exactly know how to do this in Leetcode, but let's play around with it. And then just string. We'll put the parser here. Okay. What do we need? We need. Well, let's put them up into the. Okay. Now integer part is equal to string dot is that good enough? I have to remember how to do Python, but okay. So that actually does what I was hoping it would do. Non-repeating. Repeating is string does. Oh, string is the name of the thing. String. I guess this is fine. So we will have to repeat. We'll move to the thing at the end. How do I remove the last number again? Yeah. Let's now play around with also. Just make sure that this gets it right. I think there are also some stuff like. Oh, actually, there's this one more thing. Actually, that's a good one. Yeah. Okay. That is annoying, but not undoable. Is that cheating? Also, I didn't do one without repeating yet, so. Yeah, just do a thing. If everything is still a string, okay, that's fine. Okay, let's make not strings. Oh. Who? Okay, so that's the non-repeating part. What is my? Okay. No, you can't do that because it shifts the base a little bit. Can't have a zoom. That's messy. Okay, that's fine. Maybe I'll check later then. Yeah, I won't. Okay, let's double check our input and what we expect things to be, and then we can play around with it now. Okay. Okay, sounds reasonable. And now is this even necessary then? I guess it makes this easier. It shouldn't change anything because it will be the because if this is 0, that means it's a whole number anyway. Okay. Okay. And now we have, let's figure out the base is equal to. Okay. So the non-repeating part is equal to digits of base here. And then, well, let's say denominator, numerator. Numerator is equal to not repeating. So, else int of non-repeating. Okay. Progressing very deliberately, but that's okay. And this is what I need. Okay, so is that right? Yeah, okay. So I think this is roughly right. 166 out of 1,000. Why is this highlighted right? Okay. Repeating here. And then what does a repeating digit mean? Okay. So here it means 52 out of 52 out of 99, that is. Here it means 25 out of 990. Is that how that works? Don't remember anymore. Let's take a look. Because that's 525. No, it's 500 plus 25 out of 90. No, that's not 25 out. I'm using a calculator just to make sure. Okay, so it is 25 out of 990. Okay. So that means it is repeating denominator is equal to the length of non-repeating. That's the number of nines. Something like very hacky, but I think that works. Maybe off by one. And then you times that by the denominator that we had previously, I think. Maybe? This could be 0 though. I print too much stuff. This is not right. Okay. It should be 990. Why is it just 90? Okay. Also, skip this one, which is also sad. Let me print it out again. This is just also like one of those problems of a lot of edge cases, maybe. Oh, I meant to say repeating. That's why everything's a little weird. Okay, 52 of 99, 25 of 990. Wow, that was actually surprisingly quick. Okay, I'm happy with that. Am I printing something in a weird way? Okay, repeating, because I didn't. Okay. And now we have, so this is the number that it represents in some way. And then now we have self dot numerator is equal to okay, actually I guess maybe there's just two cases. Okay. Then the numerator is equal to so there's no repeat. there's no repeating portion, so it's just the integer times the denominator plus the numerator. And so the denominator is equal to just the denominator. Okay. Otherwise, if you have repeating numbers, then it's this. Maybe, not really. Okay, so it's this times the repeating denominator. And it's this. Plus numerator times repeating plus repeating. Okay. And then now let's print this out. String integer is not an integer, which maybe is ironic, but okay. So okay, I could remove this print and then just I put it in a lot of places. Okay. Is that not how I do? I don't remember how to do string or easy string stuff, but okay, fine. Okay. I want to GCD it. Maybe not. Maybe it's fine for now. But let's make sure that this is right. I don't. Because I think this one's wrong. Yeah. I think I have it off by something. Well, let's print this. Self dot n self dot d is equal to t dot n over t dot d. That's not right? I mean, I feel like the first one is right. 175. Oh no, it's not. It's off by a factor. Right, let's bring this back again. So 99 is 25 over 990. But that should be, let's see, 5 times 990 plus 25. But This is off by a little bit. Maybe. Is it? Why is it of 9? Where did I get the numerator from? Yeah, okay. Just forgot to multiply one thing. I feel like there's also like a lot of random edge cases that I'm not considering right now. This is hard, but I do get this one right, which is happy about. Yeah, I just submitted it. Basic income with well, okay, there's no period. That's the one that I actually remember when I was typing it. I was like, oh, this has a period for no reason, but then I didn't add in that test, and that's what happens. Curse you. Okay. Hmm. And string. Cool. All right. Let me get another error. Oh, wow. Actually got it around the second time. The first time, I guess I should have gotten it or caught the error, but it's still happy enough that got it on the second try. This took 22 minutes-ish, which was a lot of typing, so maybe not 50 lines of code. I mean, there's a lot of, I don't know, very not confident typing, I guess is how I would put it. So it's like high stress typing because I feel like there's an off by one, just very, very close to something that I've done. Cool. Yeah, I mean, I think this is a hard problem just because there are a lot of edge cases. I think the thing that I would try to do, and that's what I've been to try to do a little bit, is just to make sure that maybe if I took out the input output of it faster. But the first thing I try to do is kind of convert this into a way that like there are just fewer opportunity for edge cases. I think, I mean, they tell you kind of the three type of numbers to look out for. I think if we're not using Python, I would also worry a little bit about int and doubles and stuff like this, and kind of make sure. I don't know if they tell. Actually, it's less than 4, so maybe I didn't need to worry about it that much. I could also have like one thing that I did think about was maybe simplifying the fraction. But essentially, what I do is I convert each of these numbers to a fraction containing the numerator and the denominator, and then just compare it that way. And everything here in the code does just kind of checks for that. I guess one thing that, the one thing to note is kind of figure out, and I mean, it's just something that I remember. I don't know if there's an easy way about it. Maybe it's Googleable quickly, but on the interview, I don't know how friendly that is, or at least not all the time. But like, converting the repeating number to a fraction, I vaguely remember it's like, over 99 or some equivalent of the fractional parts. But then I actually might not have, I don't know. But yeah, once you convert that, then you have like, a couple of fractions to kind of sum to each other, and then that's it. That's the way I would think about it, because I have 3 parts that are each fractions, I guess. And maybe I could have, if I have the fraction class, maybe I could have cleaned this up a little bit as well, where, you have the integer part, you sum that with the non-repeating part, which is just an easy, x over some power of 10, which is what I did here. And then the repeating part, which is another number over some number composes of 9s and 10s. Yeah, and that's kind of how and then you have those three fractions, you sum them together to get one mega fraction, or bigger fraction, which you can reduce or simplify, and then you compare it to the second one, which you do the same thing with. And that's how I did it. This is very tricky to get right on a whiteboard or probably on an interview, but you can go over a lot of these concepts. So a lot of it, yeah, on an interview, maybe depending on the kind of interview, you might not necessarily need to go, exactly pixel perfect, but the concepts are kind of, you know easy to figure out. But I don't know. I don't know how I feel about this as a new question. It is a good to program one. Uh, this is high stress for each line versus something that you might have necessarily done before. Oh, excuse me. Oh man, must be allergic to something. Excuse me. um, Whew, that gets the blood flowing, I guess. But yeah, overall, a fun-ish problem, and sorry, I'm like half sneezing. But yeah, but overall, yeah, a fun-ish problem. I mean, I actually thought there would be more edge cases than there would be, to be honest. Uh, but well, not so bad. It turned out. I mean, I did have that one, but I had it in the back of my mind, but I forgot about it. Um, but, but yeah,